Okay, so let's go through these. First one, we've got dinitrogen trioxide, molecular compound because it's got prefixes in it. Okay, so we've got dinitrogen, that's N2, trioxide, O3, N2O3. Okay, for number 2, calcium chloride. It's an ionic compound, so we have to drop and swap our charges. So we write the formula for calcium, that's 2 plus, chloride is minus 1. Okay, so when we drop and swap, we get CaCl2. Okay, for number 3, we also have an ionic compound, but this one has a multivalent metal in it because we have a Roman numeral. And what does the Roman numeral tell us? It tells us what charge to use in the swap and drop. Alright, so we got copper with the 2 plus charge with nitride, which is minus 3. So we drop and swap. 3 goes here, 2 goes there. Cu3N2. Here. They put a Roman numeral here? Okay, and then number 4, we've got magnesium sulfate, also an ionic compound. Magnesium is a metal, sulfate's a polyatomic ion. Okay, so Mg, and Mg is 2 plus. Sulfate is SO4, it's a minus 2. Those cancel each other out. And we've got MgSO4. There should not be any brackets around SO4. Questions on any of those? Okay. For the names, okay, our first one here, we've got sulfur with bromine, molecular compound, so I'm going to need prefixes. However, there is no prefix for 1 on the first element, so we've got sulfur tribromide. No capital letters. Okay, it's got capital letters, it's wrong. Okay, and there's no half marks, by the way. I don't believe in half marks. Right, so there's no half marks. If you give them a half mark, I will take it away when I enter it in the computer. So don't try to make them feel better. Okay. All right. Number 6, I've got lithium with oxygen. So that's an ionic compound. I know I don't need any prefixes on this one. Okay, so I have lithium oxide. Okay. For number 7, I've got iron with nitrogen, which is an ionic compound. Problem. Iron has more than one possible charge, so I need to indicate which one with a Roman numeral. Okay, nitrogen's always a minus 3, so this iron has to be plus 3. So we are looking at iron, Roman numeral 3, nitride. Okay, and our last one, sodium is a metal, so we're dealing with an ionic compound here. It's attached to nitrate, so we have, very simply, sodium nitrate. Okay, please give them a mark out of 8 at the top where I can clearly see it when I'm entering. Give it back to them, and when you've seen yours, put it in the box right here. Okay, so yesterday we left off, and I think we got to talking about observations yesterday. Is that right? Okay, so we were talking about how to set up the lab report, and we had talked about how the procedure, when you have to design it, needs to be an explicitly detailed step-by-step set of instructions on what to do. Okay, it needs to include, when you perform this test, not only how to perform that test, but also what kind of observations you should be making. Right? So if I'm explaining to somebody how to perform the solubility test, for example, right? I would say something like, fill the depression now to, let's say, 3/4 of the way full with water, okay, while taking the temperature with a thermometer. Observations to record would be any temperature changes, any color changes in the water, any changes in the appearance of the substance, or if the substance outright disappears. Okay, these are indications that the substance is soluble. Right? That's a detailed set of instructions on how to perform that test. How do you do it? You add this much water, fill it to here. Right? Otherwise, you got to assume they're not going to put enough water in, or they're going to overfill it, stick the thermometer, and it's going to spill everywhere. Okay, so you got to make sure that you are explicit in here's how you do it, so you don't screw it up. Okay, does that make sense to everybody? Okay, so it's going to take you a bit of time, but what I don't want to see in the instructions is get stuff, do test. add water, check conductivity. Like that's, how do I do that? I don't, those aren't instructions. That's, I don't know what that is, but it's not instructions, okay? And it's not going to help someone else perform the lab, okay? So we need a fairly good level of detail there. Okay, so we were at observations here. Charts, graphs, or any other data, calculations. Calculations sometimes go in observations, but more often than not they go in the analysis, okay? And anecdotal notes. All right, and I think I said at the end, anecdotal notes means you might write something like, today the plant looked wilted. Okay, so you might say something like that, or you know, the plant appeared sickly today. Right? That's a qualitative observation. You've kind of tried to describe it, whereas a quantitative observation would be the plant was 2 centimeters taller than last week. Right, where you've actually measured it, right, and given them a number. Those are the kinds of observations that might go in there. It might be pictures. Okay, more and more now in lab reports, we're just using your camera on your phone to take a picture of what we were doing. Okay, I mean, a picture's worth 1,000 words. Let's put lots of pictures in there. Okay, we got no problem with that. If you want to do that as part of your observations on the lab on Monday, you go right ahead. Find a place to include it. I don't mind. Okay, you just have to obviously insert those pictures into the file, which you guys know how to do. It's not hard. Okay, so those are the kind of things that we're looking at. Okay, for analysis. Okay, after your observations, what you have to do is look at the data you got. What does it say? What is it telling me? Okay, and so you're comparing it essentially and looking at, does it agree with some of the things I said? What does this observation mean? Okay, those kind of things. So that's what usually goes in analysis. Now on your guys' report, analysis is usually going to be some questions that you have to answer. All right, so you just answer the questions on your lab sheet. You don't have to write them down, or I'll already have them on there on the template and you won't have to write them down. You just have to write complete sentence, detailed, explanatory answers, or if it's a calculation, you need to show your calculations. Right? Last year I had people who didn't want to type their calculations on the computer, so they wrote them out on paper, snapped a picture of them, and inserted the picture in so that I could see their handwritten calculations, and that's fine too. Okay? We're in a digital age where all that stuff is possible. Okay? And you know what? Honestly, if it was me, I'd probably want to do it that way too. I like to actually have pen and paper when I'm doing calculations. All right? Because it's way easier to write squared and square root when you don't have to look for the symbol somewhere. Okay? So that's kind of what we're looking for there for analysis. Okay, sometimes your graphs will go in there as well if the graph is actually analyzing some data that you have. Okay, after your analysis, so once you've kind of figured out what your observations are telling you, then in the conclusion you say, my observations say this, my hypothesis said this, here's why my observations support or don't support my hypothesis. All right, so in the conclusion, the first thing you do is restate the hypothesis. Okay, so basically you just copy and paste it, right? So copy and paste it from the beginning of the report. Okay, and then you'll have, a short paragraph, a couple of sentences that accepts or rejects the hypothesis based on the results. Okay, so if the observations of our plant lab, which was our example that we were using yesterday, okay, if our observations show that plants that receive less than 12 hours of sunlight don't grow very much, plants that receive around 12 hours of sun and 12 hours of darkness grow very well, and plants that receive more than 16 hours of sunlight die, okay, that doesn't really agree with our hypothesis, because our hypothesis said the more sunlight they get, the better they're going to grow. And while that was true to a point, there was a tipping point where too much sun was bad for them. Okay? Which means my hypothesis was only partly correct, which means I can't accept it. Okay? I can't accept it at least completely. So in the conclusion then, I would say something like, here's my hypothesis, if plants need sunlight to grow and plants get different amounts of sunlight, then the plants that get the most will grow the best. I would have to say in there, based on the observations from this lab, it seems clear that there is an ideal amount of sunlight that plants require, and this amount seems to be around 12 to 16 hours of sunlight. Beyond 16 hours, plants did not grow well. In fact, most subjects beyond 16 hours died. Right? Therefore, the hypothesis is not acceptable. Right? Something like that. So I've said, here's my observations, Here's what they say, and here's why they don't accept or don't support my hypothesis. All right? The reality of it is, guys, most hypotheses are wrong. Okay? Most of the time. In real science. In our labs, they're going to, well, we're going to set it up so we can be right. Okay? It feels good to be right. So we're going to kind of set them up that way. All right, and then the last thing we have is the evaluation. Okay? And what we do in the evaluation is we identify any sources of error and we give ways to improve them. So if we were going to perform a similar lab, where we modified something, we would say, here's what we're doing. This didn't work well in a previous lab, so we're changing it to this. Okay, so in this part you would say, I had an issue with this part of the lab. It may have interfered with the results in this way. The thing about sources of error is this. They have to be sources of error that were beyond your control or that you could do nothing about given the procedure. Right? You cannot list human error as a source of error, because I see this all the time. Yeah, my group didn't do step 2, so we missed some results. And they list that as a source of error. In teacher speak, that translates to, my group and I are lazy and didn't do the lab right, so we did it wrong. That's not what you want me to think, okay, when I read your sources of error. But I see it all the time. We screwed this part up, so the lab didn't work. If you know you screwed it up, what should you do? Unscrew it up, fix it, do it again, okay? You don't write in there, yeah, we didn't do it right. Hey, Coder, you gave us these great instructions that we didn't follow, and so the lab didn't work. Really? You're kidding me. Okay? Yeah, you got to do the lab right. If you messed it up, do it again. Okay? Don't list you screwed up as a source of error. All right? A source of error is something that was beyond your control. If we were doing a lab with those plants and we were using sunlight, okay, as a source of light, and there were 4 cloudy days during our experiment, there was nothing we could do about that. Okay? We have to say that during this 4 days, there was a noticeable decrease in the growth of plants. That's because there was cloudy, and there was really nothing we could do. Had it been sunny all 4 days, the plants would have grown more. That's a source of error. Okay? Next time, we might perform the lab under artificial growth lamps where we can control a constant amount of light. Okay? There's how you fix it. Okay? It was something that was inherent to the lab, to the procedure, and it affected your lab in this way. Here's how to fix it. Does that make sense to everybody? Okay? And I usually set up the labs so there's a couple of things that could work better. All right? You're not going to hurt my feelings by pointing them out. I put them there on purpose. Okay? So look for them, be critical, say this would be an improvement. Okay? All right, does that make sense to everybody? Okay. All right, so that's how that is going to work. All right. So as I'll always do with our lab reports, guys, is I'll walk you through the pre-lab, okay? And I'll record it. This is the part you want to listen to when you're checking your lab report or doing your lab report at home, okay, and getting it finished up. You're going to want to listen to this part because I drop all kinds of hints. Okay, little things that you may forget or didn't write down or whatever that will help you as you go through. All right, so it's always a good idea to listen to them when you're doing it. All right, so our problem here, it says we got to restate the problem in our own words. So if we look at, okay, the sheet that we got, the problem is, given several unknown samples, how can we classify them as ionic, molecular acids, and bases in order to find their identity? Okay, so we got to have something in there about physical properties and finding identities. That's in your own words. That's what we're trying to do. How can we do it? Okay, that's what you've got to put down on paper. Okay, is a question that's got essentially those key points in it. All right. For the design, we got to identify and explain the variables, just like we talked about yesterday. Yes. We try not to use I, we, us, okay, or anything that kind of puts us in the experiment. Right? We try to avoid that. Now, I have how can we classify them in there as a bad example, but okay, we try to avoid doing that, especially in the hypothesis. We try to avoid that at all costs. All right. The manipulated variable is the thing that we are changing in this lab. Now, we know what the tests we're running are. Okay? they're going to be the same every time. What are we running the tests on? We're running the tests on unknown samples. Okay? Are we testing a different sample every time? Okay. So it would seem like we're manipulating the samples. Like I said, baby steps. I'm really going to walk you through this first one. Okay? So we know what it is. You guys need to explain why it's manipulated, how we're manipulating it. Okay? If we're testing a different substance every time, what's going to end up being different as a result of doing a different substance every time? Okay, we'll get to that. We'll get to the identity of the substance. But to get to the identity of the substance, every time I run the tests, what needs to be different? Okay, what kind of information are we going to receive? Let's be really specific here. What are we finding with these tests? We're finding... Okay, what are the results? I'm looking for like 2 words, and they both start with P. And that's one of the things we're going to find. It's one of these things. What kind of properties? The other word that starts with P. Physical properties. Okay? That should be different. If we're testing something different every time, we should get a different set of physical properties every time. Okay? Now, yesterday we talked also about controlled variables, and I told you you need to identify 3 controlled variables, things that remain the same every time you do the lab, or all throughout the lab, or whatever the case may be. In this case, we're running the same series of tests on every substance, okay, throughout the lab. Right? So anything that's going to remain the same throughout the lab and needs to in order to maintain the integrity of the lab is a controlled variable. I mentioned a couple yesterday, okay, but I've also mentioned one this morning twice. Okay. As we went through the manipulated and responding variables, I mentioned this variable in each one of those. So you might have to review it to get that one. I gave you the manipulated and responding, but I'm going to have you guys figure out the controlled variables. You need at least 3. Okay? And you need to say, here's how it's being controlled. Here would be the effects if it wasn't for each one. Okay? All right, the materials on your copy of the lab report are already there. Okay, so you don't have to worry about them. But we do have a hypothesis to do. The hypothesis is the most important part. Okay, then the conclusion. All right, and oftentimes, at least the beginning, the hypothesis is the most difficult part. So we need an if, and then statement. Okay, remembering that the if part deals with the premise or the problem. The and part talks about the experiment, and the then part tells us what we're going to get for results or what we're going to see happen, okay, things like that. So our problem is about using physical properties to identify things. Agreed? Okay. So the premise, what's the premise we're working on here? This experiment doesn't work unless everything in this lab has what? Every single substance has a unique set of physical properties. That's the premise we're working on. Okay? Is that every single compound in this lab has a unique set of physical properties. If that's not true, this lab doesn't work. Is that a big enough hint? If that's not true. Okay? So, the if part needs to deal with the unique physical properties of things. It's got to mention that in there. Okay? That's the whole premise we're working on, is that everything in this lab's got unique physical properties. Okay? What are we going to do in this lab? So that's the if part. The and part talks about the experiment. What are we doing in this experiment? Don't worry about typing it all out now, guys. You can listen to this again later. Okay? I mean, you want to make a little note, but you don't need to have it polished right now. Okay? In this experiment, are we running some tests? Okay? What are those tests going to find? Okay, just mention that. What you want to put in the and part is we're running these tests, okay, or we'll be looking for these specific properties, something like that. Don't use the word we, okay, and the following physical properties are, you know, whatever. Something along those lines. Talk about the experiment just briefly, okay, in the and part. Then, so the premise is everything's got physical properties. We're going to find those physical properties. Then what are we going to be able to do? Right, based on, okay, what we find. So that's the then part. Then this is what's going to happen. I'm going to get these results, and I'll use them this way. Okay, something along those lines needs to go in the then part. Okay, and you can, when you pick your groups here, you can kind of work through that and word it. You know, find a way to word that together. You know, 2 heads are better than 1. 4 heads are better than 2. Okay. No, you do need to have unique reports. It's okay if they're similar. You know, if you worked on the hypothesis together, I'm okay if your hypotheses are very, very similar. But what I don't want to see is 4 carbon copies of the exact same lab report from 4 different people. Okay, is that clear to everybody there? Okay, so yeah, you do have to make sure that, yes, you're working on this together. Yes, there's going to be similarities, but yours does need to be your own, okay, in the end. All right, so like we said, that's the hypothesis. Okay, and just so you know, on that lab sheet I gave you, starting on the bottom and going over onto the back are the rubrics, the scoring rubrics. Okay, so your design is out of 5 marks. That is your problem and your variables. Okay, and then your hypothesis is out of 5. Right, and then after that you've got your observations, I believe, data. Okay, and that's, or sorry. It says equipment and procedure. That's what you guys are making up. This is the only lab where that rubric is actually on there because you guys are making up the procedure. All right, so that's 5 marks for the quality of your instructions for performing the lab. Okay, and then under that is 3 marks for your data and observations. Now, in your document, you can see here that I've built the chart for you. Okay, it looks small right now, and you know, you might be thinking, I think I'm going to need more room than that. It's okay. Start typing in there. It'll expand. Okay, it'll get bigger. It'll be as big as you need it to be. All right. So just start typing in your observable properties, because you're right. The stuff you put in the observable properties column is probably going to be several lines. There's going to be lots of stuff you're going to write in there. All right. So be verbose. That means use lots of words. Okay. Solubility. Well, you might need to, you know, put in there, you know, a little bit of a description. Conductivity doesn't need much room. It's a number. Right, it's off the conductivity tester. pH also just a number, right? So those don't need a lot of room. All right, so that part, fill that in. Quality of that is where you get those 3 marks from. If you put in observable properties, blue, solid, solubility, yes. Okay, you're probably not going to do very well in that part. Okay, let's be descriptive there. Okay, and like I said, the compounds are just going to be labeled with a letter, right, when you go in there on the beaker. Okay, once you've got that done, and that's about as far as we'll get before we can actually do the lab. So writing out your procedure, okay, and you can see here, procedure, enter your steps here. That's where you and your group are making up the steps. I've seen some that were like 20 steps, right? And I've seen other ones where it was like, you know, this test and this test, each one was a step, and then it said like repeat steps for each one. I think that's a smarter way of using the space. They actually, now on sample B, and then that had all the same stuff again, I don't think you need to do it that way. Okay, I'd say repeat all steps for the rest of the compounds or whatever. So it's going to take up a fair amount of room. You're going to, because we said you want to be descriptive with that. Okay, for the analysis, what you need to do is, based on those observations, was sample A ionic or molecular, right? And we know which test is going to tell us that every single time 100%. Conductivity test, okay? So that's the one you'll want to use there. It'll tell you 100% for sure, okay? I mean, you'll want to look at other things as well. And then, which compound was it? So the possible identities of the compounds are up here in the materials, okay? Ammonium nitrate, paraffin, that's candle wax. You might want to write that beside it just so you remember. Paraffin is candle wax. Okay? Hydrogen chloride, cobalt chloride, cobalt 2 chloride, distilled water, okay? Copper 2 sulfate, sodium chloride, sucrose, nickel, okay, ethanol, sodium hydroxide, okay, I don't know why I have water on there twice, but I do, okay. So what I would say isn't a bad idea is at some point you might want to just go through that list and write beside them I or M, okay? Which ones are ionic, which ones are molecular, okay? That can help you when you're starting to do the identities and trying to figure out, okay, sample A was, you know, a liquid that was clear, soluble in water, had no odor, pH was 7, and had no conductivity or poor conductivity. I think that might be water, right? Because if it didn't have any conductivity, it was molecular, okay? And if it had a pH of 7 and it was clear and it was liquid, it probably was water, okay? Things like that. Is everyone following me on that? Okay, so that's what you'll be doing there, okay? So for your analysis, 5 marks is filling in that chart. But obviously you can't do that until we've done the lab and you have data to analyze. Right? Then you'll have your conclusion, copy and paste your hypothesis based on what you were able to do here and what you saw in the observations. Were you able to use physical properties to identify the substances? Okay, evaluation. Is there anything that made it difficult in this lab? Are there things that would have made it easier? Okay, and list how that would have worked. And then the class discussion, you don't have to answer those questions. That's stuff we're going to go over after I hand back the labs, or return the labs to you. Then we talk about these questions here. Okay, and then this is where I put your marks in. So when I mark your lab, I'll actually put marks out of 5, okay, or out of 3 or whatever they're out of in here, and then I'll give you a total that will appear when you get it back. Okay, so if you ever wonder where you lost marks, you go all the way down to the bottom of your report and you'll see the evaluation there. Okay, questions on that? Okay, so your job today is you can pick a group, no more than 4 people. Okay, let's try and include everybody. If you see that somebody doesn't have a group, okay, and you got room in yours, please invite them. What you need to get done: problem, hypothesis, design. Okay, so your variables and your procedure. Okay, that's what needs to get done in the remainder of today, and we might have some time tomorrow as well, okay, to work on that. That has to be done for Monday. Right? You can't go into the lab without a procedure to follow. Okay? Questions? All right, let's get to it. I put the due date on here, guys, as next Thursday. I think that's the 17th. Okay?